Hello, networking folks. Welcome back. In this video, we are going to be exploring L2LS. L2LS stands for Layer 2 Leaf Spine. So, this L2LS fabric contains Arista devices. So, L2LS is an industry standard architecture. Leaf Spine, Layer 2 Leaf Spine architecture is industry standard. So, it doesn't have to be Arista. We can use any vendor. So the architecture itself is open standards. So in a typical leaf spine architecture, we'll have spine switches, leaf switches. So minimum we'll have two spines and multiple leaves. The leaf switches can be standalone or can be in MLAG, or other vendors call it MC-lag or VPC. So the architecture itself is open standards, and every vendor can do L2LS, least fine architecture. And some of the benefits of using least fine architecture before that. So before going into that benefits, uh, least fine architecture is the go-to option for modern campus and data center. They are the backbone of one of the some of the largest data center networks, campus networks that I have seen. So leaf-spine architecture is much more. It's scalable, resilient, and redundancy is built in across the network. That we will be seeing it. So in L2LS, we have leaf-spine architecture. We have two types of leaf-spine architecture: L2LS and L3LS. In this video, we are going to be only talking about L2LS. So the difference between, let me tell you the difference between L2LS and L3LS. So L2LS, the links. It's all about the links between leaf and spine. If the links between leaf and spine are L2 links, then it's L2LS. If the links between leaf and spine are layer 3 routed links, then it's L3LS. It's as simple as that. And in L2LS, the gateway is mostly is actually on the spine. So the gateway on the S-ways will be configured on the spine, but in L3LS, the gateways will be on the leaf switches, and we'll be using EVP and VXLAN. And we are not going to deep into that. We are only going to focus on L2LS. So before getting into L2LS, let me tell you the benefits. So how, first one, it's scalable. For example, a customer, let's say a customer is, let's say, implementing leaf spine architecture. Let's say they have 5 leaf switches and 2 spines, but let's say their business is growing and they want to expand, scale up their network. Then if the customer is already on leaf spine architecture L2LS, then they can, it's very easy to scale because you will be just adding leaf switches. Let's say on the spine switch, let's say I have a 48 port spine switch, which means I can have 48 leaf switches. If I have, let's say, 96 port spines, which I can have 96 leaves, I can scale up to 96 leaves. And let's say I'm deploying a chassis, let's say 300 port chassis, which means I can have up to 300 leaf switches. So from day one, I can deploy, let's say from day one, on the day one, I can have 10 leaves. So I don't, then let's say after let's say 6 months or 1 year, I want to scale up my network, I want to add 50 and 100 leaves, then I don't have to change my spines. I can keep the same spine. I can just keep adding leaf switches and creating port channels. It's super scalable, easy to scale, and also we don't have to change the entire network. And there's so entire network we don't have to change the entire network, which means there is no downtime. And one more thing is that it's open standards. So whatever the protocols that we will be using in L2LS is open standards. Example, VLANs, port channels, LACP, STP, and MLAG, SVIs, VRRP, all these are open standard protocols. So we can use multi-vendor. I can have, let's say, I can have Arista spine, I can have Cisco leaf, or Juniper, or Aruba leaf switches. So I can do multi-vendor. If I want, let's say, if I say, okay, I want Arista for spine, let's say I want Cisco for spine, I want Arista for leaf, I want, let's say, Juniper for leaf, we can do that. Okay. and it's super scalable as well. And to put it simple, whatever below spine is L2, and whatever is above spine, that will be L3. So first, so let me explain my lab topology that I will be exploring, configuring, and will be doing a bunch of tests, ping test, redundancy test on leaf level, link level, spine level, even firewall level. Also, we'll be seeing redundancy tests. Okay, so in this setup, I have three host devices. Each host belong to different VLAN. So host 1 belongs to VLAN 10, host 2 VLAN 20, and host 3 VLAN 30. And I have three leaf switches. So leaf 1 and 2 are in MLAG, and leaf 3 is standalone. And I have two spines. Spines are in MLAG, and I have two firewalls. Uh, it is an active standby firewalls. Firewall 1 is active, firewall 2 is standby, and all the leaf switches are connected to all the both spine switches for redundancy. So I can have, let's say, if you let's say I have now, if you look at the leaf 1 and 2, I have four uplinks, two from each leaf. I can have two uplinks, one from each leaf. I can do that. So but let's say the customer, so the problem here is that if you look at, let's say if I have only one uplink per leaf, so what happens when this link goes down? What happens now? So before, let's say now I have 20 gig. Let's say these links are 10 gig links. Let's say these links are 10 gig links. Now I have 20 gig uplink bandwidth. Okay, 20 gig together. Now let's say this link goes down, then my uplink bandwidth will become 10. Then I'm losing half my bandwidth. So, but for some customers who losing half bandwidth is not a good option. Okay, they want to some people, some network engineers, they want to keep the, even if multiple link fails, even if one or two link goes down, they want to keep that over subscription ratio. They don't want to lose the bandwidth. They want to keep that. Okay, I want 20 gig bandwidth at all times. Even if one or two link goes on, I want that 20 gig bandwidth subscription ratio. Then in that case, the better option would be connecting uh, all the leaves to all the spines. So leaf 1 will connect to spine 1 and 2. So in this case, even if I lose, let's say, one or two links, I'll still have 20 gig uplink. Okay, so that is the ideology. That is the benefit of using multiple, two links per leaf. But that it doesn't have to be two. I can go up as long as, let's say, that the leaf has 8 uplinks. I can have 8 uplinks. It doesn't have to be one or two. There is no limitation on how many uplinks I have. So there is no limit, as long as the limit is actually the physical limitation. If the spine is a 48 baud, then that is your limit. If the leaf has only, let's say, 4 uplinks, then that is your limit. You are limited by the physical form factor of the switch, not the design itself. Okay. So the spines are in MLAG, and both spines are connected to both firewalls. And I'm using port channel 100 for firewall 1 and port channel 200 for firewall 2. And I'm only allowing VLAN 99 for firewall, and the firewall connectivity will be between VLAN 99. So the firewall virtual IP will be 99.1, and spine 99, VLAN 99, SVI 99 will be 99.2. So I'll be so on spine, on both spines, I'll configure a default route towards 99.1, which is the firewall virtual IP. On and on the firewall, I will configure a static route to 10.0.0.0/8 towards the spines. So on the spines, static routes towards 10 networks. The next stop will be spines. On the spines, I'll have a default route towards the firewall, which means the virtual IP 99.1. And on the spines, I'll be configuring SVIs and warp. So I have, if you want to dive deep into how MLAG works, how warp works, I have separate videos on both topics. I will add the video links in the description. You can watch it later if you want to learn these topics in detail. You can watch those videos. But in these videos, I'll be configuring MLAG and warp, but I will not go too deep into that. I'll be focusing on leaf-spine architecture, the redundancy, the benefits, especially the link failures, switch failures, firewall failures. So those things I'll be focusing on. Okay. So so without any delay, let me get into the devices and start configuring. So let me first show you the connectivity. So on the spine 1, so Ethernet 1 is connected to leaf 1, Ethernet 2 is connected to leaf 2, Ethernet 3 is connected to leaf 3, and Ethernet 5 is connected to firewall 1, 6 is connected to firewall 2, and 4 and 7 I'm using it for MLAG pure link. And on spine 2 as well, it's going to be the same. So I'm going to be using the same uh, interfaces on both spines. So it will be easy for configuring as well. You can just copy paste the configurations if you have the same interfaces on both spines. So first, before starting the configurations, so let me explain what we're trying to achieve here. So now I'll be configuring first. I'll be configuring MLAG on spine 1 and 2 and leaf 1 and 2. So I'm going to configure MLAG first on spines and leaves. Then I will configure the port channel 10, 21, and 100 and 200. Then I'll configure the SVIs, gateways, warp on the spine. So that's how I'm going to proceed. First I'll configure MLAG, then port channel, then all the VLAN configuration on the leaves. Then I'll configure the SVIs and warp on the spine. So that's how I'm going to proceed. And between firewall and spines, I'm just going to allow VLAN 99. So I don't want my host VLANs to reach firewall. So I'm just going to allow VLAN 99 only there. So let's begin. So before starting the configuration, I'd like to show you the spanning tree on spine. So show spanning tree. So if you look carefully, so right now I have Ethernet 3 is the root port. So Ethernet 3 is leaf 3. So leaf 3 is connected there. So leaf 3 is now the root bridge of this fabric. And in an L2LS fabric, we don't recommend, or nobody recommends, the leaf to be the root bridge. We want the spines to be the root, because spines are connected to all the leaves. So of course, we want all the interfaces on the spines to be designated and forwarding. We don't want any interfaces on the spines to be alternative or blocking or backup. So we don't want that. So the first thing what I'm going to do is that I'm going to make sure that my spines are root bridges. So for that, what I'm going to do is I'm going to configure, let's say, spanning tree root. I'm going to make this my spines as the super. I want to make sure that my spines are roots at all times, even though if somebody else comes with a lower bridge ID or lower priority, I will not allow them to be a root. I want my spines to be root at all times, no matter what. So my spines will be the spanning tree configure. My spines will be spanning tree root. My spines will be spanning tree root super. So when I do root super, what will happen is it will actually configure, the spine will configure its priority as 0. Let me show you that. Let me show you that. So show spanning tree again. If you look at the priority, priority is 0, because everybody else will have the default priority, which is 32,000 something, whereas the spines will have the priority of 0. So spine will always be the root bridge. So nobody else can become the root bridge. So we have made sure that the spines are the root bridge. So now you can see spine 1 and spine 2 have the priority of 0. And there is a small difference here. If you look at the interfaces, if you look at spine 1, all the interfaces are designated and forwarding. Whereas on the spine 2, Ethernet 4 and 7 are backup. So 4 and 7 are MLAG peer links, peer interfaces, which are now backup. So, so this is a behavior that we are seeing before configuring MLAG. So now let me configure MLAG. Now we'll see the spanning tree again. So let me go back to the configuration. So MLAG configuration, I already have the MLAG configuration. Since I already have a dedicated video for MLAG, so I'm not going to go step by step for MLAG. So I'm just going to, on the spines, I'm going to use the MLAG ID as my name. And on the leaves, I'm going to use a domain ID as just MLAG something. And there is a subtle difference here that on the spines, the peer links are Ethernet 4 and 7, whereas on the leaves, the peer links are Ethernet 5 and 6. So I'll just copy this configuration. I'll just copy paste this because I don't want to waste my time, because this video is gonna be a long video, because I'm going to be talking about each and every detail. I'm not just going to configure it. I'm just going to go every step. I'll show you how STP is changing, STP's behavior is changing. So everything, every single detail I'll be looking at, I'll be showing you. So it's going to be a long video. So those MLAG configurations, I'll just copy paste it just to save time. So if you want to look at the configuration, you can just pause this video, and you can just see the configurations. And I will also add the configuration links in the descriptions. Then if you want to look at the configurations, you can look at there as well. So spine 1 is done. So spine 2, I will just copy paste these configurations. Okay, MLAG is configured. Okay, MLAG, this is a standard MLAG configuration. So I have, let me show you the MLAG now. So now let me show you the MLAG. Show MLAG. MLAG is consistent, as you can see here. MLAG is consistent. MLAG. MLAG is consistent, as you can see here. MLAG is consistent. So MLAG is fine now, and I'm using the domain ID called Kavi. So MLAG is fine now. Okay, now right now both switches are now going to be acting as a single entity. Let me show you how they are doing this. So MLAG detail. If I give this command, show MLAG detail. Show show MLAG detail. So if I give the command show MLAG detail, MLAG detail. If you look closely, you can see the system ID. That is the system ID. Yeah, system ID. If you look at the system ID, you look at the system ID of both switches. Now both spines are using the same system ID. So both channels will see the same system ID. STP will see the same bridge ID. So STP will see the same bridge ID from both spines. Both channel will see the same system ID from both spines. So that is how MLAG is actually tricking all the connected devices by showing the same system ID. So now let me show you the spanning tree. If you look at the spanning tree, I'm showing the span. Let me show you the spanning tree. So spanning tree. If you look here, if you look at the interfaces, you look at the interfaces. Everything, all the interfaces are designated. And if you look at the bridge ID is same. Both switches are now using the same bridge ID. Even root ID, bridge ID, everything is same. Even the, if you look at the, and you can also see the peer interfaces as well. If you see here, Ethernet 1 to 6, Ethernet 1 to 6, okay, and if you look at Ethernet 1 to 6, so that P stands for peer. So you can also see the local interfaces as well as the peer interfaces on both spines. Both spines we can clearly see the local interfaces. You can see the priority for local interfaces 128, and you can see the 128.1, whereas you can see the peer interfaces like 200.1 on spine 1. On spine 2, it's the other way around. Local interface is that 120.201, but peer is 128.1. So STP also now synchronized by using the same bridge ID. Okay, now I've configured MLAG on the spines, and we have seen the behavior now. Now let me go to leaf and do the configuration, do the MLAG configuration. So leaf also I'm going to do the MLAG configuration now. So I'll just copy paste the configuration. Just leaf 1. This is the leaf 1 configuration. Paste. And let me copy paste the leaf 2 configuration. Quickly, I'll do that. And now I'll show you the, let me just click yes. Now show MLAG. We should be seeing that, okay, as you can see here, MLAG status is active and it's consistent, and I'm using the MLAG domain ID as MLAG. and again show mlag here as well. Mm. I'm seeing the mlag configuration is consistent, and I can see the status as active and it's connected. Negotiation status is connected. Peeling status, all these things I can see, and as well as system ID. Also, I can see the system ID, same system ID on both leaves. So that is how MLAG is tracking all the endpoints and devices which are connected to it. Let me also show you this show spanning tree. So let me show you the show spanning tree. Show spanning tree. Show spanning tree. Okay. If you look here, if you look here, Ethernet 1, which is connected to spine 1, which is the root, and all other interfaces, Ethernet 2, which is connected to spine 2, is the alternative. Whereas Ethernet 1 on leaf 2, Ethernet 1 and 2 on leaf 2 are alternative. Let me explain it, what is happening right now. So let me go back to the topology. And where is the highlight? Let me do some highlights. Yeah. Okay. So what is happening right now is spine right now a single entity. According to STP, it's a single entity. Let me clear this. So according to spine is a single entity now, and leaf 1 and 2 are a single entity now. So now I have 4 links running between them. So what is happening now is STP. Now I am running 4 links between 2 switches. It's like running between 2 switches, because both spines and leaves are in MLAB, which means single spine and single leaf logically. So STP has to block certain links to prevent loops. So what is happening right now is STP is blocking this link, and this link. So now I have running 4 links between spine and leaf, and STP is blocking 3 links to prevent loop. So that's what we are seeing there. Okay, that's what we are seeing there. So if you go here, Ethernet 1 is root and 2 alternative, and here alternative Ethernet 1 and 2 alternative. So I have 3 alternative interfaces and 1 root interface. And also we can see the peer status as well. PE root 1, 2 alternative, 3 is designated. So we can also see the peer status as well. Here you can see peer interface Ethernet 4 as well. It's a designated. Okay. Now MLAG configurations are done. Let me also show you the STP on the leaf tree as well. So spanning tree. So if you see here, Ethernet 1 is connected to spine 1, Ethernet 2 is connected to spine 2, Ethernet 2 is alternative. Let me explain again what is happening right now. Right now I have not configured port channels. That's why we are seeing this STP behavior. Right now that we have not configured port channels. So what's happening right now is both spines are right now logically a single switch, and leaf 3 is a single switch, and I'm running 2 interfaces between 2 switches. So right now what is happening is STP is blocking one of the interfaces. Okay, that is what we are seeing now. So I will once I configure the port channel, everything will be sorted. So now uh, we are done with the port channel MLAG configuration. Now let me move to the MLAG configuration is MLAG part is done. So let me go to move to port channel configuration. So now I have to configure 4 port channels on the spines. So port channel 10, 20, and 100, 200, and between spines, we are running port channel 1000, which is part of the MLAG configuration, which is already done. And between leaf 1 and 2 also, we are running the same port channel 1000 for MLAG, so which is part of MLAG configuration, which is already done. So on the spines, I'll configure 4 port channel. On leaf 1 and 2, I'll configure 2 port channels, port channel 10 and 1. And on leaf 3, I'll configure 1 port channel, which is port channel 20. So let me start with spine now. So let me go to spine now. Sorry, let me go to spine now. Let me go to spine now. Let me go to spine. So now show LLDP neighbors. So leaf 1 and 2 are in MLAG. So Ethernet 1 and 2 I have to configure them in the same port channel. Ethernet 3 will be part of a different port channel 20. Ethernet 1 and 2 will be port channel 10. 3 will be port channel 20, and 5 will be port channel firewall 1 belongs to port channel 100. So 5 port channel 100 and 6 will be port channel 200. So let me start the configuration. So interface, I'll first create port channel 10 and switch port, mode, trunk. So on the spines, all the port channels will be trunk ports. And MLAG ID, a lot of, so whenever whenever we configure port channel on an MLAG switch, we must configure the MLAG ID. So MLAG ID is mandatory for port channels on MLAG interfaces. Okay, so interface port channel 20 and say trunk, say MLAG ID, I will be doing MLAG ID 20 and I will be now interface port channel 100. So switch port, I can just say port trunk and switch port. I'm going to say trunk allowed VLAN. I'm going to say 99 and interface port channel 200 and I'm going to do the same. Oh, okay, I forgot to configure the MLAG ID for port channel 100. So these are the things that we need to be make sure that we configure all this. So port channel 200 I will configure the MLAG ID. Port channel 100 I will also configure the MLAG ID. MLAG 100. So now since I'm using the same interfaces on both spines, I can just copy paste it. So we do show history, So I can just copy paste the same. Whatever I've done here, I will copy that and paste it here. So if I give now show MLAG, now I have four port channels, both are active, sorry, inactive. So MLAG, if I show, I have four ports, MLAG ports, and all four are inactive. The reason is, let me show you why it's showing inactive. Show interface status. If I give the show interface status, all four are inactive because all are not connected. Because on the other side, we have not. Just a minute. I have not configured this portion into interface, Ethernet interfaces. My bad. Ethernet 1 and 2. Okay, Ethernet 1 and 2 channel group 10 mode active, and Ethernet 3. Okay, channel group 20 mode active. My bad. I completely forgot about this. And Ethernet 5, if I'm correct, is connected to firewall. Let me do the show LLDP neighbors again. So yep, Ethernet 5 is connected to firewall 1. So I'm going to say channel group 100 mode active. Sorry. Okay, Ethernet 5 is done. Ethernet 6 channel group 200 mode active. So now what I will do is I will again show history. We'll do the same on the spine one as well because I'm using the same interfaces. So we'll just okay, just paste. So now show interface status. Now you can see that port channel 100 and 200 are connected because firewall side configuration is already done. So that's why it's showing connected. Now if I give show interface status. Show interface status, and you can see 100 and 200 are connected because the firewall side configuration is already done. And port channel 10 and 20 is not connected because leaf side port channels are not configured yet. So let me go to leaf 1 and 2 and I'll configure the port channel here. So interface port channel 10 and switch port mode trunk and MLAG ID 10 and interface port channel 1, and it's going to be an access port. Port channel 1 is connected to will be connected to host 1. So switch port access VLAN, I'm going to say 10. Okay. Now what I'm going to do next is I'm going to assign this Ethernet 1 and 2 will be channel group part of port channel 10 mode active. Done. Now I can do show and history, and I can just copy paste it. Since I'm using the same interfaces on both leaves, I can just copy paste it here as well. Okay. On leaf 2 also it's configured. Okay, now let me show MLAG. Now I can see one active full, and I can see show MLAG. One active full. I should have two port channels, but I'm only seeing one. Let me see show interface status. Port channel 1 is not connected. Yep. Port channel 1 is not connected. I'm saying port channel 1 is connected. Show interface status. Port channel 1 is not connected. The reason is, if you see here, Ethernet 3 is actually connected to host 1 and it is not part of the port channel, which means I did not assign the port channel to an interface. Ethernet 3, I can say channel group, I can say 1 mode active. That's right. Now it should see that. So interface Ethernet 3, I can say channel group 1 mode active. Now we should be seeing port channel 1, Ethernet 3, and it's not connected. Let's wait for some time. Yep. Here it shows connected, and it shows 1 gig. Ethernet 3. Ethernet 3 is connected. Let me do that. Let me do it again. Ethernet 3 is connected. Ethernet 3 is connected. Show interface. Sorry, interface port channel 1. Let me see the configuration. Yep. MLAG is missing. So the reason it was showing not connect is because I did not configure MLAG ID. So interface port channel 1 show active. Let me see here as well. So MLAG, I need to configure the MLAG ID. Oh, sorry. MLAG 10 is already configured to, it's MLAG, actually MLAG 10 is already configured to port channel 10. So I cannot do that. Okay, I will say MLAG 1. I think that's why that was the issue. So I cannot use the same MLAG ID for different port channels. Okay, now show interface status. Yep, now it's showing connected. Show interface status. So it's now connected. 2 gig, as you can see here. So you have to be careful when configuring MLAG IDs. Sometimes you forget uh, configuring MLAG IDs. So that will cause the issue like this, what just now what we have seen, that port channel not coming up. So we have to make sure that the MLAG ID is configured on port channels. So leaf 1 and 2 is done. Configuration is done. So on leaf 2, I have to do one more configuration because I have one more host 2 is connected there. So LLDB neighbors, if you see here, I have host 2 connected to Ethernet 1, sorry, Ethernet 4. Let me see. So yeah. So here you can see I have host 2, which is connected to leaf, only leaf 2. So host 2 is only connected to leaf 2. So I will configure this interface as an access port. Okay. Let me do that now. Let me do that now. Let me do that. So, okay, interface Ethernet 4. And I'm going to switch port, access, VLAN, VLAN. I'm going to say this is VLAN 20. So VLAN 20, I did not create VLAN 20, so it automatically created VLAN. So if I show VLAN, and I can see VLAN 10 and 20 here. But let me show you something. Show MLAG. If you give show MLAG, if you see that peer config is inconsistent. If you see inconsistent in the show MLAG output, which means there is something wrong with the configuration. So the configurations are mismatching. So let me show you. Show MLAG config sanity. If you see here, the local value, if you see, you can see that VLAN, so admin status of VLAN 20 is active and MAC learning it's learning MAC addresses in VLAN 20. So, and this is the local value. So leaf 2 is actually the VLAN 20 is active as well as it's loading MAC addresses. But whereas if you look at peer value, it's not there. Let me show you. Show MLAG. It's showing inconsistent. Now show MLAG config sanity. If I do config sanity, if you look here, the local value is not present, but whereas the peer has VLAN 20. So VLAN 20 is not configured on leaf 1, but it is configured on leaf 2. So so there is one thing that we have to be mindful. So whenever you create a VLAN on one leaf, you have to do that on other leaf as well. So the VLAN configuration and the interface configuration has to match on both MLAG switches. So let me do show VLAN, sorry, VLAN 20. I'll just create VLAN 20. So now if I give show mlag, if you see now it's consistent. So now it's consistent. Show mlag. So let me explain why we have to configure the same VLAN configuration and interface configuration on both leaves. Let me explain why we have to do that. So let's say host 2 is sending let's say sending a packet to leaf 2, and the packet goes to the, let's say, to the gateway which is on the spine, then to the firewall and to the internet. Let's say the return traffic might end up coming here. Let's say the return traffic comes to spine 2, and spine 2, let's say it sends the traffic to leaf 1, because we are configuring the same port channel. Okay, port channel 10. So which means spine 1, spine 2, the spines can send the traffic to either leaf 1 or leaf 2. Let's say if I don't configure VLAN 20 on leaf 1, it will simply drop the packet. Okay, it will drop the packet. So what we are doing now, so that's why we are making sure that we are configuring the same VLAN configuration on both leaves, so that if VLAN, if leaf 1 receives any traffic for VLAN 20, it will know that, okay, I have to send the traffic to leaf 2. Then leaf 2 will send the traffic to host 2. Okay, let me show you that on the CLI as well, how leaf 1 is doing that. Let me show you that on the on leaf 1. Let's say leaf 1 receives a return traffic which is destined for leaf 2. Sorry, leaf 2 and host 2. Let me show VLAN. Okay, now if you see here VLAN 20, and if you look at the ports, if you see here peer Ethernet 4, it clearly shows that, okay, if I receive any traffic for VLAN 20, I have interfaces. So let's say now I'm receiving VLAN traffic for VLAN 20 via port channel 10. So I can, what uh, leaf 1 will do is it will send the traffic to port channel 1000, because the peer switch Ethernet 4 has VLAN 20. Okay, so that's how it is. So the return traffic might come to either leaf 1 or leaf 2. So that's why we have to make sure that we configure the same VLAN configuration on both leaves. Okay, now we are done with leaf 1 and 2. So let me check once again, show VLAN. So show VLAN. So VLAN 10, 20, and we are allowing, okay, I can see that VLAN 10, port channel 1, 10 and 1000. VLAN 20, Ethernet 4, 10 and 1000. And here you can see VLAN 10, port channel 1, 10 and 1000. And VLAN 20, peer Ethernet, peer switch Ethernet 4, then port channel 10 and port channel 1000 as well. So port channel configurations and VLAN configurations are fine on both leaves. So now let me move to leaf 3. So leaf 3, if I right now spanning tree is blocking one of the interfaces. The main reason that we are going for L3LS, sorry, L2LS, is that I don't want HTTP to block any of the interfaces. So I want to utilize 100% of my investment, 100% of my equipment, cables, transceivers. So what I'm going to do is I'm going to go here. I'm going to create port channel interface, port channel 20. I'm going to configure it as a switch mode trunk. Sorry, switch mode trunk. Next, what I'm going to do is interface Ethernet 1 and 2, which is connected to spines channel group 20 mode active. And I have one host connected here. So LLDP neighbor. If you see here, I have host 3 connected to Ethernet 3. So I will configure that as well. Interface Ethernet 3, and I will say switch port access VLAN 30. Now show interface status. So now you can see here Ethernet 3 is actually connected to the host, and it's configured as an access VLAN 30 and port channel 20, and it's configured as a trunk port, and I have 2 gig. So both Ethernet 1 and 2 are connected. Let me show you the spanning tree as well. So now spanning tree, I don't have any alternative ports. Earlier I had alternative ports. If you see here, Ethernet 2 as an alternative. Now I have just a root port which is forwarding, and I have one designated port forwarding, which is the host interface. So now let me So I have done, let me check the VLAN configuration just in case that I have to make sure that, okay, VLAN 30 is allowed on Ethernet 3 and port channel 20. So, so far so good. So leaf side configuration is done. So leaf side, what we have done is we configured MLAG on leaf 1 and 2 and port channel 10 and 20 here, port channel 10 here, and I have already configured the access interfaces, access ports for single home hosts, and trunk ports are configured on the spines as well. I have already configured the MLAG and port channels. So now I'm going to configure. I'm going to configure SVI's gateway and warp. So I'm going to configure that. So it's taking some time. So bear with me. So we're gonna dive deep into this. Okay, now let me go to spines. So I have four VLANs, VLAN 10, 20, 30, and 99, which means I have to configure four SVIs. So first I'll configure interface VLAN 10. Okay, sorry, interface VLAN 10. Okay. So I have both options. I can configure warp with a local IP, without a local IP. So for VLAN 10, 20, and 30, I'm going to configure warp with local IP, and VLAN 99, I'm going to configure without local IP. You'll be seeing that. So the difference between with local IP, without local IP. So warp is with local IP, and there is one more option is Anycast gateway, which is mostly used on the EVP and VXLAN fabric on the VTAPs. So we'll be also configuring that as well. So now, right now, each SVI will have a local IP as well as a virtual IP. So let me configure the local IP address. So 10.10.10.251, which will be the local IP, and IP virtual router address, which will be the virtual IP 10.10.10.254. Okay, this is VLAN 10. Then VLAN 20, I will configure. So VLAN 20, I'm going to say 20.20, 20.20, and virtual router IP address will be 20.20 as well, 20.20, and VLAN 30, I'll configure. VLAN 30, I'll configure local IP as 30.30. So I'm configuring local IP because I want to make sure that my individual spines are reachable. That's why I'm configuring both virtual IP as well as local IP. But you can only configure virtual IP, which I will be configuring it for VLAN 99. 30.30. So VLAN 10, 20, and 30. So the SVI and the warp configurations are done. So interface VLAN, now I'm going to configure 99. So here I'm not going to configure a local IP. I'll configure interface, sorry, IP address virtual. I'm going to say 192.168.99.2 slash, I'm going to say 29 here. So that's it. That's it. I configured the SVIs with warp configuration is also done. SVI and warp, but there is one more configuration left. So virtual, IP virtual router MAC address. So I have to configure the virtual MAC addresses as well. So all the SVIs, all the virtual IPs will use this virtual MAC address. So I'm going to say 1A, 1B, let's say, sorry, 1A, 2A at, let's say, 1B and 2B and 1C, 2C. Okay, now virtual MAC address is done. So I have to configure the same virtual MAC address on both spines. So SVI and warp configuration is done. So let me also do the same here. Interface VLAN, interface VLAN, uh, VLAN 10. So IP address and 10.10.10. Here I'm going to use 252. Sorry, /24. And I can just copy paste this one virtual IP. I can just copy paste this virtual IP. Virtual IP, I can just copy paste it. Virtual IP, so both spines will have, the virtual IP will be the same, but the local IP will be different. The local IP will be for spine 1 251 and spine 2 252. But the virtual IP, which will be our gateway IP, which is 254 on same on both spines. So next is interface VLAN 20. So I'm going to say VLAN 20, and just a minute, I will be configuring the 20.20. Then 20.20 is done. Let me, I don't want to do this, I'll just copy paste. I'll just copy paste the virtual IP. But if you are only using the virtual IP, if you're not doing, if you're not going to configure local IP, then it's basically a copy paste. You can use that. So show history, copy and paste everything, so that it will be very easy. And also the percentage, the chance of making errors is also reduced. So, and okay, 20.20, I'm going to change this to 30.30, 30.30, and it's done. So virtual IP, let me copy paste virtual IP. So virtual IP, I can just copy paste it. I can just copy paste the virtual IP. And let me do the VLAN 99. VLAN 99, done. So I can just copy this IP and paste it here. And then I will configure the virtual router MAC address. It has to be same virtual MAC address. So I configure that. Just make sure that I'm configuring it again. So now show IP interface brief. If you look here, there is something is wrong. Show IP interface brief. If you look here, all the SVIs are down. The reason is because we did not create any VLANs. If I do show VLAN, if you see here, the VLANs are not configured on this point. That's why it's showing down. So let me configure the VLAN 10, 20, 30, and 99. Now let me do this show VLAN again. Now you can see that I can see VLANs are now going through all these. And let me also do one more show IP interface brief. Yep, now you can see all the status, interface status is showing up now. So let me also do here as well. VLAN 10, 20, 30, and 99. And let me see the show interface. Now everything is showing up. And there is one more thing that we need to look. So I want to look basically. So what happens now? Let me do the show VLAN, show VLAN, show VLAN. Let's focus on VLAN 99. So VLAN 99, if you see here, VLAN 99, it's allowed on port channel 10, 20. Let me go back here. So right now, VLAN 99 is allowed on these trunk ports. These trunk ports are actually allowing VLAN 99. And I don't want to do that. I don't want that. I want VLAN 99 to be only allowed on these trunk ports as well as the peer link. Okay. So what I'm going to do that is that I'm going to create a trunk group, and I will only configure the trunk group on these trunk interfaces, so that VLAN 99 is only allowed on these interfaces. So let me do that. Let me do that quickly. So let me go back. Let me also make sure that the firewall is also configured with the same trunk ports. So this is the firewall configuration that which I configured. And if you see here, I have configured a trunk group called FW, that stands for firewall. Okay, so I will do this. I will configure the same trunk group on spine as well. So I will do the same on spine as well. Okay, now VLAN 99. So okay, trunk group, I will say FW firewall, and I'll say interface port channel. I want port channel 100, 200, and 1000. 1000 is my peer link to carry this. So now switch port trunk group, I would say, and I will say FW. So it's done now here. And let me go to spine 2 interface port channel. Sorry, not interface. So VLAN 99. I'm going to say trunk group, and I'll say FW, and say interface port channel 100, 200, firewall 1, firewall 2, as well as my peer link 1000. So switch port trunk group FW. So now if I give the command show VLAN, if you see here, yeah, VLAN 99 is now only allowed on these trunk ports. This is not, VLAN 99 is not allowed on port channel 10 and 20, which is towards my host, which is inside my fabric. So show VLAN. Now if you see here, VLAN VLAN 99 is only allowed on port channel 100, 200, and 1000. Let me show you there. So VLAN 1000 is, sorry, port channel 1000 is this, port channel 100 and port channel 200. So VLAN 99 is only allowed on these trunk interfaces. Okay, we have done that. Okay, everything looks good now. So now let me do one thing. From let me go to my spine. Hmm, Let me go to the spine. Let me ping one of the 10.10.10. 10.10.10 is not reachable. Let me just a minute. Let me check. There's something here. Okay. Oh, okay. Okay. Let me go back. So VLAN. So VLAN is okay. Show IP interface brief. Show IP interface brief. You look here. So let me also show you the virtual IP. Show IP virtual router. If I give this command, you can see that 10, 20, and 30. Show IP interface brief. You can see that. Oh, sorry. So IP virtual router. So show IP virtual router. I can see 10.10.10.254 is up. So let me quickly check the host side configuration. So sorry, there was some configuration is on the host part. So it has been sorted now. So the issue was with the host part where the port channel configurations were there's some issue with the port channel configuration on the host part. I just resolved it. Now I will try to ping 10.10.10.2. Sorry, again 10. Yep. Now we can reach 10.10.10.10. Sorry, I did not use the ping command. So we can reach 10.10.10. Let me also try to ping 20.20.20 as well. Let's see 20.20.20.20. Yep. We are able to reach 20.20.20. Let me try 30.30.30. So right now I'm able to reach all the hosts. So let me just open the host CLI. So let me open the host CLI. So give me a moment. So let me open the host. So host one. So there was some issue with the port channel. So I corrected that. So was able to reach the host. Sorry, gateway. So now let me go to host two. I'm gonna ping 10 dot. Sorry, host two is to 20. 10.20.20.254. So I can reach the whole gateway now. So let me ping 10.30.30.30. Okay, from host also I can reach the gateway. So I can reach the gateway. So let me do the inter VLAN ping. So let me try that. Let me try inter VLAN. So 20 dot from host one, I'm trying to ping host two. Yep, inter VLAN routing is happening. Inter VLAN routing is happening. Now 30.30.30 also I'll ping. So 30.30.30. So I can reach the host from all the hosts. I can reach the gateway as well as I can reach other hosts as well. So inter VLAN routing is happening, and gateway also I can reach. Let me try to reach the firewall subnet. 99.2. I can reach the firewall SVI on the spine. So this is 99.2 is on the spine, that virtual IP which we configured earlier. So let me ping the firewall. Yes, 99.1 is the firewall SVI. So I can reach the firewall SVI as well. Now I can reach firewall IP 99.2, which is the firewall network on the spine. Okay. Now what I will do is let me do something. Let me do something. So I'm gonna do a continuous ping, repeat ping to the firewall. So let me see what is happening. Repeat. So repeat. I'm gonna say 100 and interval. I'm gonna say no. First I will do it with the gateway 10.10.10.254. Repeat. Okay, repeat. I'm gonna say 100 and I'm gonna say like let me say interval every 1 second. So every 1 second, so I'm going to send a total of 100 pings in every 1 second. So before doing that, let me go here. So let me do something. Let me go back to my this one, my topology. Let me go back to my topology. What I'm going to do now is, so now the entire fabric has been configured. Okay, configured. So now we have to test the resiliency, failover, and redundancy. So all these now we are going to do the tests now. Okay. So what I'm going to right now, I'm going to ping from host 1 to the gateway. So okay. So what I'm going to do is first I will shut down this interface. I will start the continuous ping. Then I will shut down this interface. Then on the leaf 2, I will shut down this interface. Then this interface. Okay. And then on leaf 1, I will shut down. Let's say I'm not going to go. Let's say I'm not going to say. Let's say I'm going to shut down this interface. But how many links I'm going to shut down? 1, 2, 3, 4 interfaces. So we are going to be doing like 4 interface failure scenario. Okay. So let me start the ping now. Let me start the ping now. Okay. I will be. Let me start the ping now. Okay. I will go here. Okay. This is the host 1 starting the ping. Now pings are going through. Now I'll go to. Let me go to. Let me go to. Let me go to. Just a minute. Let me go to. Let me go to. Let me move the leaf here. Let me move all the leaves here and spine here so that it will be easy for me to do. Okay, leaf 1 and leaf 2. Okay, I'm going to go to leaf 1. I'm going to say show LLDB neighbors. So we are already 50 past. So now what I'm going to do is I'm going to shut down Ethernet 3, which is connected to host 1. Interface Ethernet 3. I'm going to say shut. Okay, the pings are continuously going. We are not seeing any downtime or any packet loss so far. So leaf 1 done. Let me go to leaf 2 and now show LLDB neighbors. So now I'm going to shut down Ethernet 1 and 2, which are connected to spine 1 and spine 2. So losing both links is actually very rare. So pings draw. If you look here, 0% packet loss. Okay, let me start it again. So now what I'm going to do is on the leaf 2, I'm going to shut down both interface Ethernet 1 and 2, which are connected to the spine. I'm going to shut down that. And if you see here, let me show you show interface status that I just want to show you that. If you see here, Ethernet 1 and 2 are disabled and the port channel 10 is completely, it's not connected. So right now, what is happening? Let me go back to the design. So right now, I've shut down this interface, this interface, this interface. So right now, traffic is going like this. From there, it's going like here. From here, it's either taking this path or this path. So right now, next I'm going to shut down this interface. Okay. Next, I'm going to shut down. Okay. Next, I'm going to Ethernet 1. Sorry, leaf 1. I'm going to say show LLDB neighbors again. Okay, it's already there. So now I'm going to shut down Ethernet 1, which is connected to spine 1. Interface Ethernet 1, and I'm going to say shut. And the pings are still going through, no loss. So interface status, you can see the port channel is still connected, but Ethernet 1 is actually connected. Okay, now let me go to the topology and we'll see what we have done in this. So right now I've shut down this interface. So host has to send the traffic here. I've shut down this interface and this interface. The leaf is actually now forwarding the traffic to leaf 1. I've shut down this interface. So leaf 1 is now forwarding the traffic to spine 2. So now we can see the redundancy. We can see the redundancy from host 1's perspective. Host 1's perspective, we can see the redundancy. Let me also do it on host 2 as well. Let me do it from host. Let me do it from host as well, host 2 as well. So let me go to host 2, and I'm gonna say repeat. I'm gonna say 100. I'm gonna say in the, well, 1 second. So leaf, actually leaf. Okay, no shut. Let me give no shut here. Let me give no shut here. Okay. Let me show you the MAC address table. MAC address table. Let me show you the MAC address table. MAC address table on leaf 1. If you see here VLAN 10, it's port channel 10. VLAN 10. There's IP. Let me go to the show version. If you see that, okay, 4152. So 4152 is actually, if you look at the leaf 1, 4152. Right now, I shut down that interface. Right now, the interface which is directly connected to host 1 is shut down. But if you look at the MAC address table, 4152, now the port, it's saying peer link, port channel 1000. Let me go to the leaf 2, show MAC address table. If you look here, 4152, it's now port channel 1. So when leaf 1 receives the return traffic for 4152, it knows that, okay, I have to send it to port channel 1000, which is connected to leaf 2, which is my MLAG peer. So leaf, so that is how the return traffic uh, comes. So now interface, let's say Ethernet 1, if I give no shut, if I give no shut, sorry, not interface Ethernet 1, interface Ethernet 3, if I give no shut, I give no shutdown. Now if I look at the show MAC address table, now if you will see 4152 is now directly connected to port channel 1. If port channel 1 goes down, then it will say that, okay, port channel 1 is down, so I cannot directly send it to host 2. So I'm sending it to my MLAG peer, which is connected to port channel 1000. Okay, it's very straightforward. So now let me go to leaf 2. Leaf 2. So show LLDB neighbors. Sorry. Show LLDB neighbor. So leaf 2, you can see host 2 is connected to Ethernet 4. So now host 2, let me go to host 2, and I'm going to start the continuous ping. Let me go to the topology and explain what I'm going to do now. So now I'm going to ping from host 2 to the gateway. Okay. So ideally the traffic should go like this. So now what I'm going to do is first thing what I'm going to do is I will start the ping, then I will shut down this interface, then I will shut down this interface, then the traffic will go like this. Again, then I will shut down this interface. Then it will go like this. Okay, we are going to do the same here as well. So here we are going to see 3 link failures. We are going to simulate 3 link failures here. Okay. Okay, let me start the ping now first. Let me start the ping first. Okay, and host 2, I've started the ping. Okay, host 2, I've started the ping. Now Ethernet, uh, so interface Ethernet 1, which is connected to, let's say, Ethernet 1, which is connected to spine 1. So I'm going to shut it down. I shut down Ethernet 1 on leaf 2, and the packets are still going through. We are not seeing any packet drop. Let me go to Ethernet 2, and I will shut down this interface as well. So shut down. Okay. Now I have shut down both interfaces from leaf 2, and we are not seeing any packet drop yet. I have shut down both either this interface and this interface as well. Sorry. There was some, okay, something. Okay, just a minute. I'm getting some noise here. Sorry for the a little bit delay. There was some noise in the background. So what I'm going to do now is, I have shut down this interface and this interface. Right now the traffic is going like this. So now I'm going to shut down one of these interfaces as well. Okay. So let me do that as well. Let me go back to the topology, and let me go to Ethernet leaf 1, and I'm going to say Ethernet 1, and let me ping stuff. And you can see here 0% packet loss, 0% packet loss. You can see that. Again, I am starting the ping, and leaf 1 I'm going to shut down. Okay, and the pings are still going through. We are not seeing a single packet drop. So right now what is happening? Let me go back to the topology and explain. So right now the traffic is going here. from host 2 to leaf 2. Since these interfaces are down now, the leaf 2 is sending the traffic to leaf 1, and since this interface is down, leaf 1 is sending the traffic to spine 2. So that's what happening. So we can see the seamless failover, interface failover, port channels. I'm handling the load balancing as well. Okay. So next, what I'm going to do is, next from host 3, I'm going to test the failover scenario. So what I'm going to do is, since the host 3, sorry, leaf 3 is standalone, so I have only 2 links, so I can only see single interface failover. Single interface failover, because if I shut down both interfaces, then I will lose the connectivity to the gateway. So I can just shut down one interface, which I'm going to do it now. So let me let me go to host 3, and I'm going to give a repeat 100, and uh, I'm going to say like interval. I'm going to say every 1 second, and let me go to leaf 3. Just a minute. Leaf 3 is actually on the other side. Leaf 3 is actually leaf 3 is part of this stack. Yeah, leaf 3 is here. Let me move leaf 3 to here, and okay, okay. Now I have leaf 3. Okay, interface Ethernet 1. So right now, show LLDB neighbors. I will show the neighbors now. Ethernet 1 is connected to spine 1, Ethernet 2 is connected to spine 2, and Ethernet 3 is connected to host 3. I start pinging. Host 3, things are continuously going. So I'm in Ethernet 1 now. So now I'm going to shut down. So we are not seeing any packet drop yet. We're not seeing a single packet drop, even though we shut down one interface. Now I'm going to no shut this interface. Next I'm going to Ethernet 2. So what I'm going to do is, now I'm going to shut down Ethernet 2 as well. So to see that failover. So now I've shut down Ethernet 2 as well. Now it's using Ethernet 1. So we can have a single link failure. So it can be either Ethernet 1 or 2. So the link failure, that redundancy and the active forwarding is working. So the gateway is reachable regardless of multiple link failures. We can clearly see that. That is one of the most important benefits of using a layer 2 leaf spine, using port channel, VLANs, warp. So warp gives us active gateway. We are able to achieve this. Okay. So next, let me do one more thing. Okay, let me do one more thing. So now we can see the gateway reachability from all hosts. Okay, so let me unshut all the interfaces. Uh, no shut. Show interface status. Okay, okay, all the interfaces are now now shared. Uh, so show interface status. I will, let me see if there any interfaces are blocked. So nothing. All the interfaces are okay, connected. Let me see here. No chat. Let me bring all the interfaces up now. We are going to now test the firewall failover. Firewall side failover also we'll do. We'll test it now. Okay. So interface status. So firewall side connectivity also I'm going to test. Interface Ethernet 1 is actually, I have to give no chat. So now let me do the show interface status as well. So gateway is reachable. So now all the interfaces are restored, everything is showing connected. Okay, all the interfaces on the leaves are like connected. Okay. Now let me open the firewall CLI. Okay. So I have opened the firewall CLI. So firewall CLI. Let me show you the show VRRP. If you see here, this is the master, VRRP master. You can see the virtual IPv4 address, and you can see the virtual MAC address here. And let me go to firewall 2 as well. Show VRRP. So the firewall 2 is the backup. You can see that this is the status backup, and you can see the virtual IP 99.1 as well as the virtual MAC address as well. Okay. So now what I'm going to do is, I'm going to ping from my host, ping from the host. Okay. So I'm going to ping from the host, and we will see the. Let me just a minute. Host, let me bring it here. Firewall, let me bring it this side. Firewall, let me bring it this side. Okay. Firewall, okay, firewall 1 and 2. So on this side, I'm just going to ping from the, okay, let me try, okay, sorry, 1, I'll try to, okay, okay, 1 is reachable. So one is reachable from host 1. Okay. So right now, let me show you the. Uh, okay. Now what I'm going to do is I'm going to let me also open the spines as well. Let me also open the spines as well. This is the spine, not this one. This is the spine. Yep, 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 yep. Let me move the spines as well to here so that you can see that. So what I'm going to do now, let me go back to the topology. So we have tested the gateway failure as well as link failure scenarios. So both spines are acting as an active gateway, which we were able to see it by shutdowning multiple interfaces. Okay. Now what I'm going to do is I'm going to I'm going to go to active firewall 1, and I'm going to shut down the port channel 100. Okay, I'm going to shut down the port channel 100, and the firewall 2 will become active once the active goes down. The standby will become active. That will take about 2 seconds. We'll definitely see some downtime because we are using VRRP. We are not using warp. Since we are using VRRP, we'll be seeing some packets, at least 2-3 packets going, 2-3 pings going down. We'll be seeing that because we are using VRRP. So VRRP does not gives us that high availability, active redundancy. So there will be a slight downtime that we can expect. So we can do that. Then I will shut down one of these interface so that the packet will be going from here. Okay. So first I am going to shut down port channel 100 on firewall 1. First I will start pinging. I'll start the ping. Then I will do the. Uh, Let me go back to host 1. Let me do the repeat command. Repeat. I'm going to do 100, and I'm going to say interval and 1. So pings started. So let me go to the firewall 1. This is firewall 2. Let me go here. So this is the master now. So I'm going to go to interface port channel 100. So I'm going to say shutdown. So port channel 100 is down, and there was some packet drops. We were able to see ping 1920 were dropped. I can see 18. After that, I can see only 21. There was some slight downtime. We are able to see. We are able to see some slight downtime. Let me go to the firewall 2, and if you look now, firewall 2 is the master. Before it was a backup. Now it became a master. It became the master. But we were able to see a slight downtime because the VRRP failover is not seamless. That as seamless as warp. The warp gives you that flexibility of seamless failover. So let me go to spine now. So now right now firewall 2 is the master. It's now firewall 1 is down. Okay. Now let me open the spine. So spine 2, I'm going to show LLDB neighbor. Okay. So Ethernet 6 is connected to firewall 2. I'm going to shut this down. So interface Ethernet 6. So as you can see, so 2% packet loss. That 2 ping drops. Yeah, that's that explains the efficiency of VRRP. So let me start again. Now I'm going to go to here, Ethernet 6 on spine 2, which is connected to the firewall. I am going to shut this down. Now it is actually going through the traffic is now going through spine 1. The traffic is now going through spine 1. It is now going through spine 1. So I'm going to give no shutdown here. Okay, I'm going to give no shutdown here. Okay, now I'm going to go to spine 2, sorry, spine 1. Spine 1, the pings are continuously going through. So spine 1, show LLDB neighbor. Okay, now I'm going to shut down Ethernet interface 6 here. So before I shut down the interface on Ethernet spine 2, now I'm going to do it here as well. So shut down. So now the pings are still going through. These pings are, we are not seeing a single packet drop here on the we are not seeing any single packet drop. It's seamlessly going through. The pings are continuously going. The traffics are going. Even we have seen multiple link failures. Even we have simulated a firewall failure as well. So we can see that L2LS with MLAG and port channel is gives us the redundancy, active forwarding, load sharing, and also STP is completely eliminated. And you can see here that zero packet loss. Okay, interface Ethernet. 6. Let me show you the MAC address table on the spine. So MAC address table. So if you see here, VLAN 99, let me go to the firewall and show version. I will see the show version. So firewall MAC address is 9508. Right? If I see, if you see here, 9508, this guy knows that, okay, it is behind, it is actually port channel 1000, which is the peer link, which is, so whenever it receives the packet traffic for this MAC address, this guy will send it to the spine one because Ethernet 6 is down right now. So now I'm going to say no shut. When I give no shut, and now if I see the MAC address table, now we'll be able to see port channel 20, port channel 200. Before it was showing port channel 1000. Where is it? Yeah, before it was showing port channel 1000. As soon as I no shut that entire interface, now it's showing port channel 200. So that is how MLAG works. And so let me come back to the topology. So well, let me see if I have missed anything. So so far now we can see the multiple link failures, even though there are multiple link failures and multiple, just wait, there is some noise. Even though there are multiple link failures, multiple switch failures, spine failure, we can see that high availability and load sharing as well. And thanks for watching this video. This video is pretty long, but I have covered most of the things. And if you have any questions, you can drop your questions in the comment sections. I'll be answering all your queries. And I believe that you are now master of layer 2 leaf spine fabric. And thanks for watching this video. And I'll be also posting videos on layer 3 leaf spine as well. And thanks for watching this video.